Similar to part A, we are going to start by labeling the information provided. P is the midpoint of OC, so that tells us that OP is equals to PC. APQ is a straight line, which we can just remember that. AQ is M of AP. Let's look at the line AQ and the line AP. Both of them do not have vectors on them, so let's check AQ first. To go from A to Q, we can go from A to O, followed by O to Q. However, we do not know what is the vector OQ. We can also go from A to B, followed by B to Q. But we also do not know what is B to Q. Hence, we do not have a vector for AQ. Now let's check AP. To go from A to P, we can go from A to O, followed by O to P. On first glance, you may think that you cannot find this vector. We have another way, which is to go from A to C, followed by C to P. Either one of these ways will work. Let's look at this method here. AP can be obtained by going from A to O, followed by O to P. Even though you think that we do not have the vector OP, remember that we did find the vector OC in part A, and OP is actually half of OC. So by filling in, we have negative 3A, which is AO, and half of OC. By substituting OC as 2A plus 2B, we will get an expression for AP. We expand the bracket and simplify to get an expression for the vector AP. Hence, vector AP is negative 2A plus B. Putting it back into the information provided, we can now find the vector AQ, which is M times of the vector AP. By expansion, AQ is negative 2MA plus MB. Now let's move down to the next thing, which is OQ equals to NOB. OQ is the line here, and OB is the line here. While we do not have the vector OQ, we have the vector OB, which is 6B. Hence, OQ can be written as n times of OB, which is n times of 6B. We get the vector OQ as 6 and B. Let's combine all the information that we have. We know the vector OQ, and we know the vector AQ. These two vectors can be combined by the line OA. Combining it in vector form, we write OA is the same as OQ plus QA. OA is given to be 3A. OQ was found to be 6NB. And we found AQ. So to get QA, we are going to put the negative of AQ, which is positive 2MA minus MB. Expanding and simplifying, we have this equation now. Finally, we are going to compare the vectors A and the vectors B. Notice that vector A will never be the same as vector B, so we can compare them separately. Vector A has 3 on the left side and 2m on the right hand side. From here, we can find that m is equals to 3 over 2. As for vector B, notice that there is no vector B on the left hand side, so that is 0, and on the right hand side, we have 6n minus m. Substituting m to be 3 over 2, we can now solve for the value of n. (6n) is equals to 3 over 2, and hence n is equals to 1 over 4. Putting it back into the equation, OQ is 1 over 4 of OB. Let's look back at the figure. If OQ is 1 unit, then OB is 4 units, which tells us that QB must be 3 units. Hence, the ratio of OQ is to QB is 1:3. Similar to part A, we are going to start by labeling